follow up on the comments. You know, what will make GO-BGC, SOCOM as well, but GO-BGC successful in following up on Hetty Edmonds and Emily Smith's comments. You know, I really encourage users to start to plan and think about things they can do with the data. You know, there is a large amount of data out there now. So GO-BGC, we're just starting. First 11 floats in the water and sending data, and you know, even you know, international collaborations to analyze the data. You know, are really going to be key to the success of the program. The other you know, comment, and we've seen this at the Argo steering team meetings, but we need to really step up the international planning on deployments. So, you know, have made the point that GO-BGC doesn't have ship time, but other nations are stepping up. So and deploying floats as well, and so Katja's talk just now showing you know, the Canadian plans in the Western Atlantic. We really, you know, will need to really start an active collaboration and planning with Canada in both the Atlantic, and I would expect as well, Katja, in the Pacific too, to some extent. I mean, you've spoken about the oxygen floats that are now operating in the Pacific, and you know, I think to get the 1,000 floats evenly distributed that we wish, you know, we all have to interact in a significant way.
Yeah, I agree. And I mean, we can sort of look at Core Argo, who are doing that quite successfully, and sort of learn some lessons without making the mistakes first that maybe they made, if they made any, I don't know, but yeah.
Yeah, absolutely. So, you know, that's the challenge really to build this array. It's going to take significant international collaboration. Lynn showed the Go ship lines, which only get, you know, occupied once every 10 years, but you know, many of them once every 10 years. Getting floats spread globally is going to be a bit of work. Emily, you popped up, and I expect you might have something to say. Is that?
Yes, Mike Patterson asked a question in the window, and I started to type out an answer and felt it would probably just be easier to say. So he was asking about, you know, looking long term, is NOAA going to plan to sustain BGC Argo beyond the NSF project support? And so something that folks outside of agencies might not understand is right now we are planning for FY24 budget. So federal agencies plan 3 years in advance, meaning this next spring, in a year from now, we will be planning the FY25 budget. And we would need clarity from NSF of what their intention is before we made any type of request, large requests like that, to take this on, because it would be very hard to sell if NOAA says we're going to take this on and then NSF says we're going to keep going. So that's something we've got to sort out. It's not beyond the scope of possibility, but we've got to figure that out first.
Yeah, totally agree on the point that federal, you know, this is a interagency discussion that is above my pay grade. Yes. Anyway, back to the you know, the challenge of getting floats in the water. There are going to be challenges associated with ramping up production as well, and so I think that we need to work closely with our industrial partners in all of this. And Katja, you spoke to the role that Canadian companies, for example, and I think there were European colleagues that, I'm not looking at the participants, but I know that the EU is also very active in you know, looking at sensor development and so on. But I expect to see, you know, new sensors arriving on on the horizon. The UVP profiler is a nice example. Lots of interest in expanding radiometer capability from four wavelengths to the hyperspectral region, and I know that there are floats in the water in the EU that have that are testing that capability now. So I think that we will expect to see that the this the parameters will evolve, and they have already evolved. That I mentioned earlier, that oxygen has gone from a Clark electrode that worked well when it worked, but didn't always work, and evolved into the optical oxygen sensor. And I think that we will continue to see sensors in the system improve their capabilities. I mean, that we're just early on in the really significant ramping up of the program. So gosh, I'm neglectful in my comments. Otherwise, I would be glad. Let's see, I should look at the chat. Somebody is asking, is there any good global merged gridded reanalysis product of data from satellites and subsurface from Argo? At the G7 workshop, which was last month, this came up as a similar topic. Building merged data sets, and point I made in my talk, that there's a huge synergy between BGC Argo satellite observations and ship-based data. And I think it is a challenge now to the community to start to put together a data set that really merges all of those products and looks at the various parameters that are observed in the different programs and finds a way to make them numerically compatible. The example being chlorophyll. So we need to be sure that chlorophyll from a float is compatible with chlorophyll from a satellite, and the HPLC chlorophyll from a ship. And ultimately, then taking all of those data sets and gridding them, I mean, is going to be a huge service to the numerical modeling community. They have a desire for gridded products, a huge service to the fisheries community. So it was very apparent in the food web discussion and in fisheries, the Kara Wilson's talk on fisheries. I think that right now we have a hard time getting above, in the ecosystem, getting much beyond chlorophyll with the current sensors that we have right now. But what BGC Argo can do, and can do very nicely, is map the environment and really understand parameters like oxygen that control the distribution of pelagic fish like tuna, and really start to understand how the species understand the basic environment that species operate in. So I think that merged gridded products have a huge future. I know that in the SOCOM program there are a number of people looking at ways to do that, and I don't know if anybody wants to speak to that. But that there's a big opportunity there. There's an awful lot of oxygen data now from BGC Argo all around the world. Well over half of that data has now gone through very serious quality control and adjustment, and is ready for scientific applications. And really one of the first things to be done with that is to create products. Oxygen distributions, mapping OMZs as an example, remapping OMZs with what had been fairly sparse chipboard data to, really start to look at change. So a large number of floats in the Arabian Sea and Bay of Bengal, and there have been a number of floats in the Eastern Tropical North Pacific, and using those to look at OMZs would be a huge, it'd be a big undertaking, but I think it'd be a huge service to the community. If we could really, look back at that. Katja showed a slide, which shows the number of oxygen profiles. I think, Katja, yours was the North Atlantic, but it's true globally that profiling floats now dominate the availability of high quality oxygen profiles. And I think that we can really start to look back at ocean deoxygenation and just really update the distribution of oxygen and OMZs and shallow oxygen maxima and so on in the ocean. At this point, I would be glad to entertain any more. I'm looking back at the questions. Gridded products. Question for Emily, long-term sustaining. Who is working on hyperspectral inclusion in the EU? Eric, that's a question from Eric Rehm, and I can tell you that Argo Germany has a number of floats with hyperspectral. Name is escaping me right now, but Henry Bittig is involved in that, so Henry would direct you to that. One issue brought up by the Float Tech breakout was a desire for additional funding for sensor improvement. That's from Eric, and so I totally agree. And I'm proud to say that much of the sensor development in the U.S. has been done at the Monterey Bay Aquarium Research Institute, and we've been successful and able to sustain that because we've had long-term support from the David and Lucille Packard Foundation. But I think there needs to be an avenue like that for the rest of the community, longer-term sustained support. You just, hard to go from the initial proposal, which kind of funds a concept, NSF style proposals that fund the concept, to making a really hardened sensor that can be deployed on floats. That funding for the next transition doesn't really exist in the US. There is in industrial development, that's known as the Valley of Death. There's a lot of money for development. There's a lot of money to incorporate things in operational systems, perhaps, but there is nothing to transition them from development to operation. It already actually says that. Eric's got it right there, the Valley of Death. Yes. Emily is responding, sees that as a priority. And Emily, I don't know if you want to say anything about that.
I can. It's, I've already help fund the thermometer improvements, the pH sensor, the oxygen sensor at UW. So it is a priority. I can plan to continue to do that. I know Hetty also commented that NSF will also continue to do that. I'm sure she's like me. It's as we have funds, and it's as this community raises the issues. As much as I know, I'm a big picture person. I'm not down in the technical details of when a sensor is not putting out the output we expect. So it's up to the community to also help us know when we need to fund these types of projects.
Yeah, absolutely. And to some extent, it's Emily, meetings like this where the community can provide input on, the need to move to, multi-wavelength fluorescence or hyperspectral radiometry, things like that. But definitely, I think Argo needs, BGC Argo, we need to always be refreshing our technology as we've done with oxygen. We're not, when you build an operational array, you don't do it with experimental sensors, but as new technology becomes available and is developed in the community, we need to be aware of that, and as appropriate, move it into the array, which is to keep us at the forefront of operational observing. Good question from Andrea. As the array grows, how can we reduce redundancy in tool and data product development between groups? How did Argo do this? Or is redundancy ideal to find the best option? And, you know, I don't know whether we should have Steve Reiser answer that question, or Susan Wafels if Susan is on. But I don't think, I think that Argo has had equivalent redundancy. If you go to the Argo website and look at the variety of products that are available for things like mixed layer depth or ocean heat content, there are, you know, always, you know, multiple groups doing that. And it is much like the, you know, the temperature records in the earth. There are always different groups doing it with different technologies, and so they're having a bit of competition. I think is good.
I think this is Steve. I think Andrea is right, though, that if you look back at Argo, there in the beginning, the first several years, there were lots and lots of these, and they many of them converged on a winner that was the best one and was the most the one that was used by the most people. And some of those winners are still out there after 15 or 20 years, and they're still being updated all the time. I like the idea of having lots of different groups do this and see what comes out of it.
Mm-hmm. Yeah. I mean, that's sort of the element that is the, you know, the competitive, I guess, you know, entrepreneurial way. And because whether you're gridding the data, so there's a comment from Allison, by the way, on gridding data. Efforts underway to create gridded products at UW, at Scripps, and it was interesting. We had at the SOCOM annual meeting a few weeks ago, we had within the SOCOM project itself, were there four different talks on different ways to, and quite different ways to create gridded BGC products in the ocean, using the data to really improve mapped products. So, you know, kind of like we would create a weather reanalyses. So you take the model, you take the data, you find out why the model doesn't fit the data, you fix the model and really use the model to create the high resolution data. But it's really driven by the data versus other technologies to you know, not objectively different, some well beyond objective analysis ways. I don't know, Allison, if you're on, if you want to speak to that briefly, but there are, you know, lots of ways to map data. Not hearing from Allison, Steve, and I know Steve as well is looking at under ice maps and yeah, so it's and somebody made the point yesterday about the in the discussions about the very high correlation between physical variables and biogeochemical variables, often on small scales, and using all of the high resolution Argo data combined with BGC to produce improved mapping products. So that definitely is happening, and people are going forward doing that. I'm looking at the questions. We need, let's see, so great question. Now, that was Allison's reply. We need more research to develop the best techniques, so redundancy is ideal. Thank you. I'm pondering the questions here. Let's see. And as Allison says, collaboration is good to avoid repeating the same things. That is absolutely true. Answer from Hendrik Bugener that it's the ICBM, Institute for Coastal, I don't know, anyway, the University of Oldenburg are working on hyperspectral radiometers on floats using the Trios Ramses sensor. But the comments are coming faster than I can read them. Lynn Talley is saying redundancy in products is important, different approaches and caveats, and okay, good. I'm going to write this one down, Lynn. You can't have a winner until there are multiple entries. that we will archive that. What is the max depth for BGC Argo floats, and do deep Argo floats include BGC sensors? So BGC Argo floats 2 kilometers, 2,000 meters is more or less the maximum depth. There is, interestingly, a big push for deep Argo to put oxygen on the deep Argo array. I know that Virginie Terry, Ifremer, one of the lead scientists in developing deep Argo, has put oxygen on many of the Ifremer deep floats, and really, from a physical oceanographic perspective, as a water mass tracer, they, they've made the argument that every deep Argo float should have oxygen on it. In particular, when the oxygen floats, if we can do an air oxygen calibration, if the oxygen sensor is placed so that you get an air value in the float surfaces, you'll get a really valuable record of oxygen throughout the ocean, all the way to the seafloor. And in principle, there should be a large gradient. It should be a small gradient in oxygen near the seafloor due to oxygen consumption in the sediments as well. And really interesting science could be done with oxygen gradients near the bottom, understanding sediment oxygen consumption and carbon flux to the sediments. Will be harder to do for other sensors like nitrate and pH. We assume that the deep ocean is our stable reference. We need continual updating of that stable reference from GO-ship type observations, but our sensors are not as perfect. And Argo itself, they adjust their oxygen, their salinity sensors in the midwater, assuming that's a relatively constant reference. And it's a challenge for them now developing salinity sensors that are stable enough for the lifetime of the float that they don't need a mid-ocean reference. But right now, as pointed out in Yui Takashita's talk and Tanya Mauer's talk, we assume that we can make mapped fields at 2,000 meters and use that as a reference for sensor drift. So going deeper with like pH and nitrate will be hard. Particle sensors, though, optical backscatter sensors to the bottom might also be another option. See, how can we involve nations that don't deploy floats and would benefit from using the array? So in a national level. So first of all, I think that engaging, nations internationally, training people to use data. So the C-READ program came up as an example of international communication. But I think that we need to really, essentially have, on this workshop, we had 25 nations involved in this workshop. But we need to be very active in encouraging nations that all around the world to appreciate and use the data. 40% of the world ocean is somebody's EEZ, and we need people in those nations to appreciate the data that is going, that we hope to be collected in their EEZs by floats transiting through. The ocean change, doesn't respect borders. So acidification, warming, changing nutrient fluxes, changing fisheries will affect all nations. And just having more data will help understand that. And having the various nations, the scientists, the communities understand what the data is about, how to use it, is really, something that we need to make sure. So I was very pleased to see the broad range of nations using this attending this workshop, and I think that we need to keep working in to encourage all nations to understand and value the data. I think the data access workshops were great in that regard. Let's see, scrolling back down through the questions. Yeah, so Mike Patterson is in front of my last comment. Are there challenges in data sharing from BGC measurements within country EEZs? And if yes, what strategies for addressing them to meet open data sharing goals? So Argo, so every nation has territorial rights to regulate what happens in their EEZs. Argo operates under a UN agreement from that floats in EEZs, may collect data. The nations still have a right to disallow. So the international agreement is unlike a research cruise where you may take a year getting clearance for your ship to enter another nation's water and sample. Argo profiling floats are automatically notified to nations. So the process is automated, and a nation can still ask that when a float enters their EEZ that the data be turned off. That just doesn't happen. And that was true for the core Argo variables. And a year and a half ago, that permission was through a really great effort by the Argo steering team led by Breck Owens. That and IOC in particular, Albert Fisher, that permission for a somewhat automated submission of clearances was extended to BGC Argo. And so when a BGC Argo float enters another nation's EEZ, the nation is automatically notified. And so we don't.
Well,
Yeah.
I'm gonna jump in, Ken, for a second.
Thank you,
It's
Emily.
not- So when floats drift into EEZs, not deployed, but drift into EEZs, they continue to transmit data. There are 12 countries that have requested they get notified when this happens. And that goes to the country who deployed the float. So in the US, I get those emails every Friday, and I then notify the proper country of where the float is drifting into their EEZ. To date, only one country has ever requested to have Argo stop transmitting their data when they're in their EEZ. Everyone else is fine with you transmitting it. They just want to know, those 12 countries just want to know when a float's coming into their waters.
Yeah. And so that was true for core Argo, and that agreement has now been extended to BGC Argo. So again, so that was a huge lift. The Argo steering team, really, I mean, to support us, made that happen. Breck Owens led that charge and, presented to the IOC, and it was approved unanimously, by the IOC nations. So as Emily says, you have to have explicit clearance, may take you a year in advance, whatever, to deploy a float in a nation's EEZ. But when they drift in, it's automatic notification. A nation still has the right to have us turn off the sensors, but it's rare to have that happen. And one of the reasons this comes back to the, our need to educate and inform and really train people to use the data everywhere to make sure that, the program, people support the program and that they see the value of this data for their nation. So those two comments kind of go together. And thank you. So I'm down to the end of the questions here. Going back to see if I skipped any other. We are coming up to our 1:15 time, but any other questions? If not, I want to thank everyone who participated in the workshop and made it happen. OCB in particular, and US CLIVAR for their support in making the workshop happen. The National Science Foundation, and as well as NOAA and NASA in terms of funding support for US BGC Argo that's gotten us to this point. has been, really, really appreciated, and I think really forward-looking by the agencies to support this. And Steve Reiser and his colleagues that organized the workshop, and all of the speakers that did a great job, and all of the participants in the workshop. We had a little bit of technical difficulty there, but I think that I attended the MATLAB one, and I am just totally blown away by the coding that I now have available to me. So this is really, really great. Any last words, Steve? Would you like to say anything at the end as we go? This was really your effort. Steve wrote the proposal that funded this.
Well, I'd like to thank all the participants. When we started, we thought, well, maybe 100, 150. We had well over 300 registered. I don't know if we had that many people actually log on at any given time, but it's great to see this global interest in BGC Argo and in GO-BGC, and it's when you think of where Argo was 20 years ago and where it is now, and you look at GO-BGC where it is now and where it will be in 5 or 10 years or 20 years, it's very it's there's nothing but optimism there about what we're going to learn about the ocean from all of this.
I think this will really, as Argo has done for, transforming our understanding of, a variety of things well beyond the original vision of Argo, which was, really something about ocean heat content. And it's everything from mixing to circulation to the overturning circulation. BGC Argo, I know what we're building it to do, but what it will be used for is, really, I don't think any of us really fully appreciate that. And so it's going to be really exciting. Somebody said at the SOCOM workshop a few weeks ago that a great time for early career scientists. It's a huge opportunity. And if I will, as my last statement, write proposals to NSF, to NOAA, and, make it clear that you're using the data, because that is what will keep this going. Thank you all. And we're 6 minutes early. Anything else from anyone? If not, thank you all.